Hello and welcome to another video from Plodware. This time we're going to look at using an Adafruit MCP2221A breakout board to drive an lcd1602 display via and I'm not sure how to pronounce it, a Heevhas IIC I2C board. There is a gotcha in this demo. It took me quite a while to sort out what was going on, and once more it was because I'd fallen into a trap of thinking wrongly. The problem I found was that when I tried to run the lcd1602 from the 5V pin of the MCP, that I kept losing USB connectivity. Now, running the LCD from the 3V pin of the MCP, well, that worked, but it wasn't very, the contrast was poor and the brightness was low. So that wasn't very satisfactory. Now, as a new out-of-the-box board, the MCP is strapped to run at 3V. You can see that down here. Sorry, here. What I found was that to improve the contrast brightness and to maintain USB connectivity, I had to cut and strap the MCP to run at 5V. That's cutting here and strapping here. So it, I wouldn't say it should look like this. This may not have been done too professionally, but this is the result we were after. No. The only reason I could, or explanation, was that at first I tried to run the 3V out of the box MCP2221A and provide 5V from an external power supply for the LCD. And I thought that would be it. But the problem was, as soon as I tried to connect the clock line and the data line between the two boards, that I'd lose USB connectivity. And then a thought struck me that maybe the 3V logic on the MCP pins, the clock and the data, was somehow incompatible with the 5V logic being applied by the pull-up resistors on the LCD board. So that's why I decided to try cut and strap, and as soon as I did the cut and strap, get it at 5V, everything worked fine. Now, as always, there is a disclaimer. This video is provided for informational, educational use only and is neither sponsored nor solicited. Where reference is made to any third-party organisation, source or documentation, then that reference was made under the assumption of fair use. Other than being a user of some products referred to in this video, Adafruit, Microchip Technology Incorporated, Microsoft Corporation, Heevhas, Hitachi, and SparkFun Electronics, I have no connection with any of these companies, their employees, representatives, or subsidiaries. Let's run the demo. I've already downloaded PWScripter and installed on it the demo script. I've hooked up the hardware, haven't given it power yet. I'll plug in the USB cable now. We'll run the script. The script is going to initialize the MCP2221, and then it's going to initialize the LCD board, define two user-generated characters. It's going to write a string of characters in a character-by-character mode, so it'll be slow, a hello world message, and then it'll use a faster write method, writing a number of characters in one go over the I2C interface. Let's just run it. We'll click on the execute lines, Here we are. Hello world. Either side of hello world are the two user-defined characters. 5 seconds of that, then it does it quickly. And that's the end of the very simple little demo. The demo script highlights. The demo script is based on a PDF that I found at sparkfun.com. This is the link. It concerns the Hitachi HD44780U, which is, I believe, the dot matrix liquid crystal display controller of the lcd1602 board. The script has been reduced to the bare bones to support access to the lcd1602 via I2C from an MCP2221A. After removal of comments, the script is about 150 lines long. In essence, the demo provides 3 capabilities: send a command byte, send a text string, and define a customer character. If you want to run this demo, you will need some software resources. Specifically, Microsoft Windows 7, 10 or 11 running on a desktop or a laptop. The DLL MCP2221_DLL_UM_X64 from Microchip Technology Incorporated. The freeware PW Scripter interpreter from my website. A script NS-MCP2221A-LCD1602-I2C, also from my website. Details about locating and installing the DLL, PW Scripter and its script are given in other Plodware videos.